Lesson 6.6, Factoring Trinomials of the form x squared plus bx plus c. There's no coefficient on the first term. Okay, at this point, we've done GCFs, we've done difference of squares, and we've factored by grouping. And then the two most common types of factoring we'll have to do is trinomials. In this lesson, we're doing trinomials with no coefficient on the leading term. And in the next lesson, our trinomials will have a coefficient on the leading term. Okay, so no coefficient or having a coefficient. So examples would be x squared plus 5x plus 4 or 2x squared plus 9x plus 10. These are examples of trinomials we would have to factor. So in this lesson, again, we're only doing trinomials without a coefficient on the first term. Okay, there are two different methods that we can use. A factor and sum table, which is the most commonly learned one, and then a technique I call the big giant X. Okay, so factoring these trinomials when both b and c are positive, so you have plus plus. Okay, so for example, we have b squared plus 8b plus 7. So method 1 is our factor and sum table. So what we do is we take the factors of the last term, so c. So factors of 7, and then we add them together and find their sum. Well, 7 is prime, so it only has two factors, 1 and 7, and the sum is 8. What we want is for this number to match this number, and it does. And so therefore, how we factor this is we take b plus 1 and b plus 7. Our factors of 7, 1 and 7, go here in the parentheses. The b comes from the fact that we're working with b squared. Okay, method 2 is the big giant X. And the way we do method 2 is we take a big giant X, we put a multiplication and an addition. And I'm looking for two numbers that when I multiply them, they make 7. That's our last term, so here I'll draw it. We want C and B. This B and this C. So we want to multiply to make 7 and add to make 8. So we think of two numbers that will multiply to make 7. 1 and 7, they add to 8. So those go here and here. And then those are the numbers that go inside of our parentheses. Another example, we have a squared plus 11a plus 18. So method 1, again, is our factor and sum table. So I'm looking for factors of 18. That will give me a sum of 11. So I'll start with 1 and 18. Well, those add up to 19. 2 and 9 are factors of 18, and that adds up to 11. So I have found my factors. If that hadn't worked, I would try then 6 and 3, which would have given me 10. But 2 and 9 worked. So this will factor to a plus 2, a plus 9. Using our big giant X, which is method 2. Again, we make a big giant X, make a multiplication and an addition. I want to multiply to make 18 and add to make 11. 2 and 9 multiply to make 18 and add to make 11. So I have a plus 2, a plus 9. The factor sum table is good if you're not very comfortable with a lot of mental math, like thinking about multiplying and adding in your head. The big giant X saves time if you're able to come up with factors and add them in your head quickly. The next type we have is if B is negative and C is positive. So this number is negative, this number is positive. And what that means is our factors are both negative. Because a negative times a negative is a positive, but a negative plus a negative will give us a negative. So for our example, I have k squared minus 13k plus 40. So I'm looking for factors of 40 and their sum. And keep in mind again, because this is negative, my factors need to be negative. So I have negative 1 and negative 40. Those will add up to negative 41. Negative 2 and negative 20 will add up to negative 22. Negative 4 and negative 10 will add up to negative 14. Negative 8 and negative 5 will give me negative 13. So here's the ones I want to use. If I had done my big giant X, I put the negative 13 there, I would have had to come up with that in my head, and the way I do that is I would just start running through factors. I'd say 2 and 20 is 22, 4 and 10 is 14, 8 and 5 is 13, and then I would realize that 8 and 5 would work. And in both instances, I get k minus 8, k minus 5. Now, it doesn't matter which order you write those in. This is also a correct answer because multiplication is commutative, which means that we can multiply in either order. Okay, so for our next example, we have x squared minus 14x plus 12. Making a factor and sum table, we want factors of 24 and their sum. So I have 1 and 24, and I need those to both be negative because my C is positive, but my B is negative, and that gives me negative 25. I have negative 2 and negative 12, which will give me negative 14. So those are my factors that work. If I made the big giant X, I would put a positive 24 and a negative 14. I would start thinking, perhaps I would think, oh, 6 and 4, nope, that adds up to 10. 8 and 3 adds up to 11. 2 and 12. Eventually I would get there, and my factor is x minus 2, x minus 12. Now we have a situation where B is negative, positive, and C is negative. So when we have C negative, this means we have one positive factor and one negative factor. And then when B is positive, this means the positive factor is larger. Because when we add a positive and a negative together, we subtract the numbers, and the number with the larger number, we keep that sign. So the positive number or factor would be a larger number. So here's an example. I have n squared plus 4n minus 12. So I'm looking for factors of 12, negative 12, and their sum. Okay, and I want the sum to be positive 4. So if I say negative 1 and positive 12, that gives me a positive 11. Or if I reversed that, that would give me a negative 11. Okay, so if you want, you can think of it as, instead of thinking of it as a sum, you can think of it as a difference. And I can say 2 and 6 have a difference of 4. I want my 4 to be positive. That means my 6 needs to be positive and my 2 needs to be negative. Making a big giant X, I'd have a negative 12 and a positive 4. And again, I start thinking of factors of 12 and their difference. Okay, 1 and 12, the difference is 11. 3 and 4, the difference is 1. 2 and 6, the difference is 4. And I say, okay, I want 6 to be positive and 2 to be negative. So I factor this as x plus 6, x minus 2. For my next example, m squared plus 2m minus 24. So factors of 24, and we have their difference. If I use 2 and 12, they have a difference of 10. If I use 3 and 8, they have a difference of 5. Obviously 1 and 24 won't work. We have 4 and 6, they have a difference of 2. My 2 is positive, so my 6 is positive. So I'm going to have a negative 4. So that'll give me m minus 4, m plus 6. Using my big giant X, negative 24, positive 2. I'd go through factors in my head, subtract them, come up with 6 and 4, and realize that because 2 is positive, 6 needs to be positive, and get the same result. Now, the last situation we have, C is negative. C is negative still results in 1 positive, 1 negative. And then when B is also negative, this means that the negative factor, not negative, negative, is larger. Okay, so this time we're going to want a difference again, but we want our negative number to be the larger number. So for example, I have a squared minus a minus 90. So I'm looking for factors of 90 with a difference of 1. If I do 9 and 10, they have a difference of 1. I want that 1 to be negative, so I make my 10 negative. Using the big giant X, negative 90, negative 1. I'd come up with 10 and 9. I want it to be negative, so I make the 10 negative, and I get a plus 9 times a minus 10. And for this example, I have p squared minus 5p minus 14. Factors of 14. And that difference, if I do 1 and 14, the difference is 13. If I do 2 and 7, the difference is 5. I want my 5 to be negative, so I make my 7 negative. Using the big giant X, same idea. Come up with 2 and 7, I'd see that I want my 5 to be negative, so I'd make my 7 negative. And I'd have p plus 2 times p minus 7.